Alrighty, example E. Again, we are simplifying. We are dividing complex numbers. Complex numbers meaning we just have an I involved. It's an A plus BI form. And we're going to answer in A plus BI form and reduce all fractions. So in the last video, I told you that if we want to, we need to rationalize the denominator is what this is actually called. When I get rid of the i's, because I told you that an I in the denominator is not acceptable. It's not mathematically accurate. So to do that, I said we had to multiply by the complex conjugate, which was the same exact binomial, except I changed the sign of the I part, my imaginary part. So because this was originally a plus, I'm going to multiply by -3 minus 2i. The top, the numerator, is always multiplied by the same thing. Do not try to give me the complex conjugate of the numerator, all right? It's going to be the same thing. Whatever you multiply the bottom by, you will multiply the top by, the same thing. Please don't make that mistake of trying to change this to a plus. That is not how it works. The bottom, your denominator, tells you where to go. So this one is a little longer than the last one. We do have a shortcut for the denominator. I showed you in the last video. It's always going to be your a squared plus, always a plus, your b squared, right? That's the formula down there. When I multiply complex conjugates, it's always the a squared. In this case, my a is -3, plus my b squared, and my b is the number 2. It is never, ever, ever the I. So I have a -3 in here, I have a 2 here. This is always going to end up being positive. -3 squared is 9, plus 2 squared is 4, and 9 plus 4 gives me a 13. My denominator will be a 13. My numerator, there is no shortcut for it. Well, there is, but -3 times -3 is 9. -3 times -2i is positive 6i. -2i times -3 is another positive 6i. And -2i times -2i is positive 4i squared. All right? I know whenever I have an I squared, we have discussed it's just going to change the sign of its coefficient. So 4i squared is like a 4 times a -1, and that would really give me a -4 here. Okay? If I'm combining like terms, my -4 will add with my 9. 9 minus 4 gives me 5. And as far as the i's, these do not cancel because they're the same sign. So 6i plus 6i gives me 12 i's. And they will each get their own denominator, which was the number 13. You get a 13. You get a 13. And that is your final answer. Not so bad. All right, E2, same deal, same thing over again. I want to multiply by the complex conjugate of the denominator in order to rationalize the denominator. Look at all these big words. So instead of 1 minus 4i, I'm going to multiply by 1 plus 4i, both in the denominator and in the numerator. I'll go ahead and use my shortcut for my denominator. I know because these are complex conjugates, it's always going to be an a squared plus a b squared. My a is the number 1. My b is the number 4 or -4. It doesn't really matter because it's going to get squared anyway. So if you want to call it -4, you can. If you always want to take the positive case, you can. But 1 squared is 1, and -4 squared is a positive 16. So that gives me a denominator of 17. On the top, there is no shortcut. I need to FOIL. 2 times 1 is 2, plus 2 times 4i is 8i, and then, 3i times 1 is 3i. And 3i times 4i is 12i squared. My I squared is really a -1, so this is really 12 times -1, which means it's actually a -12. That -12 will combine with the 2. 2 take away 12 gives me -10. And then I'll combine my i's. 8i plus 3i is 11i. 11 i's. And they both get their own denominator, which is the number 17. And that is my answer.